So Mark Kuster from Texas, and today I'd like to talk a little more about NCSLI's digital metrology efforts. So by way of introduction, for completeness, I've got some acronyms here. I think probably most of you have seen these all before, but perhaps not the MII. That's NCSL's particular digital metrology effort. And we've dealt quite a bit with accreditation scope, so you'll see SOA throughout the slides, and also this new idea, the M layer that Blair mentioned, basically a fundamental layer for quantities and units to support digital metrology. Well, Tom, I think the slide advancer has quit. There we go. So just today's topics, a little bit about digital transformation, NCSLI background, and a little deeper look into the MII, followed by a short conclusion. So digital transformation, I think everyone knows here how much the IQI has mattered in terms of the economy, acceptance of products across borders, interoperability of components from different economies, and also, of course, to the scientific and other fields of endeavor. But we see problems. They're not necessarily new problems, but they're increasing in importance. So we're losing a lot of value by spending a lot of money on labor. We've done a fair job of automating our basic measurement systems, but not so much the professional labor, scientific and engineering labor, and that's expensive. Of course, also in terms of the sheer numbers of instruments we see coming on the scene, especially in the IoT sector. And of course, as always, everyone wants more and more inexpensive and faster service. We think digital transformation will solve these problems, at least help them. But unfortunately, metrology has lagged behind many other industries, as you saw in Blair's slides, for example, in the travel industry. Some of these industries have completed essentially a digital transformation. Some are in the middle of it. But we see within the MI initiative, higher quality and reduced costs coming from automation as usual, when we automate those professional services. And of course, new value emerging from that digitalized measurement information, along with new products, services, and businesses that we probably don't even imagine at this point. We say it might work because it will not work if we don't make it fit for purpose and if we don't champion it for adoption. So just digitizing information doesn't really work. If we put our certificates and whatnot in PDF wrappers or XML format or whatever, that just changes the wrapper while prolonging all the weaknesses of our manual systems. And more importantly, that retains the ambiguity that's preventing these documents from being machine actionable. So we're stuck in the same square. So we think to make the transformation successful, we should really rethink our processes from the ground up to make sure that we leverage the technology. Because we have a lot of manual shortcuts and pragmatic practices in our systems today, simply because it's not valuable for human labor to do some of these things that machines would do very inexpensively. And then secondly, of course, championing adoption up and down the traceability chain and across the breadth of the industry is critical. So if you think about it, no one ever asks for a streaming music service to replace their phonograph. And by that, we mean that consumers don't really drive demand. It's the innovators and the entrepreneurs that market the products that have value, that really drives demand. So we're taking a build it and they will come attitude. Of course, that step from the phonograph to the streaming music service, skips a few steps there, but you get the idea. Now, it's very encouraging, the whole theme of this year's World Metrology Day, Digital Metrology Era. The BIPM, the OML statements regarding today, they're very encouraging to me. So you see things like exciting digital technology, revolution, machine actionable information, interoperability, and they've gone they've gone the further step of setting up a CIPM committee to develop this fundamental SI digital framework to support this operation within their domain. So very exciting, very encouraging to see that this year. Looking a little bit at the NCSLI, I think probably most of you are familiar with it, but in case not, began in America in the 60s, but it's long since become an international organization. It's volunteer driven, centered around measurement science. We do have an annual conference and publish standards and quite a few recommended practices and other publications, and also offer tutorials and webinars for training. And of course, the Metrologist magazine and the Measure Journal. But in 2015, NCSLI reconvened its automation committee to focus on this MII idea that we've been kicking around for a couple of years. So they charted it to develop digital documents and facilitate products around the idea. You can find information on that in the Metrologist magazine starting around 2013, and occasionally in the CalLab magazine. But for full information, go to this wiki.site and get a little deeper insight. Our activities mainly include awareness and development and collaboration around digital metrology. So we try to engage in the discussions going on around the world in this topic, and of course maintain a presence at the annual conference to promote the ideas. We do actually develop some within the committee, and we have various collaborators, commercial and non-commercial, and hope to acquire some more. If you're interested in joining us, I think we meet every Monday about 8 a.m. your time, so feel free. Just a few of the projects listed here, past, present, and future. We'll talk a little more about those later on in the presentation, but you can look at that back for the record later on. So let's look a little deeper into the MII. So there on the right, you have the definition, MII, Measurement Information Infrastructure. That basically boils down into standards for communicating and sharing measurement information without human intervention. So we see it through this model here on the left, in which we have three formal documents: the instrument specifications, calibration certificates, and the accreditation scopes, through which we communicate the measurement information in the measurement economy. And of course, the problem is that it takes a metrology expert to generate these documents, to transmit, receive them, interpret them, and use them. And we want to change that. So where to start? When we first looked at this problem, we immediately realized the difference in orders of magnitude in the number of instances of these documents and the entities involved. So in order to get a product out reasonably quick time, we elected to focus on the accreditation scope simply because it has so many fewer instances of the documents and the entities. And since these documents all involve measurement information and should share a common data structure, we hope to leverage that in order to produce the instrument spec and certificate document formats. Now, we'd established some design requirements. They're mostly irrelevant for today's presentation, so I won't detail them, but they're there to ensure the immediate functionality of these documents as well as their long-term success. So back to rethinking what we do. When we looked at accreditation scopes from ABs around the world and different labs, we immediately realized that the systems that work well enough for humans would not at all work for computers, because we describe quantities in free text, so everyone uses a different description. The measurement units don't really help that much because we associate various quantities with the same units, not to mention the endless number of dimensionless quantities, all using the unit 1. And there's various other issues with scales, exceptions, and problems with the SI, that cases where it works for humans but not so much for machines. So we first built a quantity and unit database. So we made the database revolve around quantities rather than units so that we could tie these concepts together. And if you think about machines reading documents, they require metadata, data about the data, in order to understand what the document contains. And for metrology, metadata means a description of the measurand. So we came up with the idea of these MII taxons and started developing a standard taxonomy. And so as an example, you can see a simple taxon here, measure voltage.dc. And we would use that to tag the data in an accreditation scope, a particular CMC, such that machines would see that and understand that if they saw an instrument specification document that tagged a particular function with the taxon source.voltage DC, then the machine would understand that that lab has the capability to calibrate that instrument function. Excuse me. And then turning it around, the calibration lab would issue a certificate with its calibration results tagged by the taxon source.voltage.dc. So that ties all these links together in a machine actionable way. Now, that was our testbed database. It obviously doesn't have global visibility or global interoperability, and we haven't defined any scales and various things related to operations on those scales or the relations between quantities. So for example, if you wanted to search for an instrument that uses some kind of a probe, sensor, transducer that translates one quantity to another, we'd like to have some relations between quantities so that you could search for a CMC or an instrument by either quantity, and the computer would take care of the details. So we're looking to generalize this a little bit. And so we're contributing to this concept of the M layer. So currently, as you know, we record our quantity values using a numeric value and a unit or some other reference. And this M layer idea would expand, firstly, to expand the concept of a unit to generalized scales, not just ratio scales, but all scales. And then importantly, it would add this third element of aspect. So this bracket Q represents a unique identifier into some global registry, so that when you record this data digitally, every machine knows what quantity we're talking about. And so that would smooth the computations and handling of data within digital systems. So that's our current level of development. If we step back into the past a few years, you'll see we created a few prototypes and concept demonstrations. So this was our first one, just to show the power of digital transformation once you get this data in digital form. So in this case, we set up a server that would take digital accreditation statements and digest them and validate them and integrate them into its database. And then you could go to this website and do a very rigorous search by a particular quantity, in this case voltage, and a particular quantity value, if you like, and if you like also an uncertainty requirement. And then it would list all the labs and their CMCs that met that requirement, and you could download that accreditation statement. So that works very well. It only had a limited amount of data, but it demonstrated the concept. From there, we went to Qualer Search. I think this website is still out there and usable. What this project did is capture 250,000 CMCs from the ABs that issue scopes from North America and somewhat internationally, and put them in a database searchable by quantity. And so here we're searching for 100 degrees Celsius temperature. And you can see in this section of North America, all the labs that claim to have that measurement capability. And then if you refine the search to 3000 degrees C, then you see how the labs dwindle who claim that capability. So that's kind of a very powerful, just one example of many that you can see leveraging this technology. From there, Fluke Calibration started a project they call Qubit. So this project is seeking to go out and capture the specifications of every measuring instrument in the world. So they estimate approximately 6 million of those, and currently they've captured about 500,000, 500,000. So it's got every, you can go there and search for model and instrument, and you can pull up the specs. You can generate a cal data sheet for your calibration, and it just shows some more of the power. Now, this isn't specifically an MII project. It's more of a Fluke project, but Fluke participates on the committee. And when we get to the point of issuing a digital structure for the instrument specifications document, we look forward to having millions of data sets to immediately fill those documents. This also highlights the point I made earlier about championing support. If we go back to Qualer, the manager that drove their end of the project at Qualer moved on to Fluke and became head of their software division. So you can see how managers have an opportunity to get involved and make a real difference. This is one of our latest efforts. It's the taxonomy editor. So we mentioned the Measure-And taxonomy earlier, and this tool allows us to edit and maintain that taxonomy. It doesn't show the details, but behind each of these taxons is a definition for the quantities involved, the influence and input quantities that you want to have if you're going to do an intelligent search for a capability or an instrument, or you're going to calibrate one of these instruments. So this is a new tool. It's kind of out in a beta form for people to test and for us to refine. You actually find this out on GitHub. You can install it. You can build it from source. And along with that, we have the accreditation statement editor. So this is a tool or similar to the tools that we envision for producing these digital accreditation statements. So we do away with Word, we do away with Excel, and whatever non-fit for purpose tools that we currently use, and we use something fit for purpose to generate and share those accreditation statements. So just in conclusion, I'd like to reemphasize the importance of rethinking our processes from the ground up. I think both Brett and Blair alluded to that very strongly. I think it's important. Let's get rid of our manual shortcuts. Let's discard these pragmatic practices. Let's champion the adoption. And we think the M layer and the taxonomy are important elements for this. The M layer for digital systems, the taxonomy for making these digital documents interoperable, and of course the norms to standardize all this. So with that, I thank New Zealand, MSL, for the opportunity to speak, and also the long-standing work that they've contributed in this area. And we would like to collaborate with anyone in their digital metrology efforts, so we hope to do that. I'd like to point out our conference in Dallas in August. If you go to the call for papers, you will find it technically expired, but in actuality, they will entertain more presentations and even a virtual presentation from New Zealand if you care to participate. So thank you for your time very much, and I'll open it up for questions.